What if I told you that the cold doesn't kill life, it transforms it? What if, in the coldest waters on the planet, evolution had broken its own rules, creating creatures so large they seem to have come straight out of an old horror movie from a time when dragons and sea monsters were real? I don't know if you're ready for this, but in the next few minutes, you're going to find out why the Antarctic oceans don't just harbor life. They create giants. And more than that, you'll understand how a place where everything should die became the nursery for the largest invertebrates that ever walked or crawled across the face of the Earth. Get ready, because what you're about to see will completely change your perspective on the limits of life. Now imagine an ocean covered by miles and miles of thick, impenetrable ice. Absolute silence. No sound of waves crashing, no cries of seagulls. Only the distant creaking of ice shifting upon itself like a sleeping giant. Crushing pressure in the depths. Temperatures ranging between 1.8 degrees and 2 degrees. So close to freezing that the water should turn to ice, but it doesn't. It remains liquid, dense, saturated with minerals and oxygen like nowhere else on the planet. No sunlight reaches these depths for months on end. No abrupt change of season, no sudden heat, no tropical storms. A stable, ancient world, almost frozen in time, as if evolution itself had decided to pause here. Here, where everything should be small, fast, and fragile to survive the extreme cold, nature did exactly the opposite. Colossal creatures crawl slowly along the seabed, leaving trails that resemble the paths of biological tanks. Slow but inevitable predators dominate the depths with a patience bordering on terrifying. And animals that in other parts of the world would measure only a few centimeters, here reach meters in length. It sounds like science fiction. It sounds impossible. It sounds like someone has scaled up life's controls. But it's not anymore. It's real. It's measurable. It's Antarctica. And the most fascinating thing, we're still figuring out why. Science calls this phenomenon polar gigantism, or in more technical terms, Bergmann's rule applied to marine invertebrates. Without complicated terms, the idea is simple and at the same time absolutely terrifying. Cold water contains much more dissolved oxygen than hot water. This is basic chemistry. The colder the liquid, the more gas it can hold. That's why ice-cold soft drinks have more bubbles. That's why aquarium fish need oxygenators in warm water. And that's why the polar oceans are veritable liquid oxygen bombs. More oxygen allows larger bodies to survive. Large animals need more energy. More energy requires more oxygen. In tropical waters, oxygen is scarce, so bodies remain small. But in Antarctica, oxygen is abundant. The limit disappears. Cold temperatures slow down metabolism, making larger bodies more efficient. Think of it this way. Keeping a giant body functioning in hot water is like driving a truck at high speed. You burn fuel too quickly. But in cold water, the metabolism slows down. The biological engine runs in economy mode. Suddenly, being big is no longer a disadvantage. It's an advantage. Extreme environmental stability. Antarctica doesn't have scorching summers or unpredictable winters. The temperature varies very little throughout the year. This means that animals don't need to expend energy constantly adapting. They can invest all their energy in growing. The result? An environment where the biological limit that governs the size of animals throughout the rest of the planet simply ceases to exist. And the central question arises, inevitable and unsettling. Antarctica reveals how life can grow immensely, or does it show how fragile that balance truly is? Because if these giants depend on a frozen and stable world, what happens when that world starts to melt? Absolute silence in the depths. Thousands of meters below the surface, where the pressure would instantly crush a human being, something moves, invisibly, without haste, without sound. A colossal squid, Mesonychoteuthis hamilton. The giant squid is the largest invertebrate on Earth, not the longest. That title belongs to the giant squid, but the heaviest, the most robust, the most real. More than 500 kilos of muscle, tentacles, and pure brute strength. Some captured specimens exceeded 10 meters in length, but scientists believe that even larger individuals are swimming in the depths, untouched and unknown. Its reddish, translucent body absorbs the little light available in the depths, making it almost invisible. It doesn't run from threats. It simply approaches unseen, like a shadow that takes shape only when it's already too late. Its tentacles don't just have suckers, they have sharp, rotating hooks like blades, capable of tearing through flesh and scales with surgical precision. When it grabs something, there's no escape. The prey simply disappears into the depths. With no natural predators, except for very rare sperm whales willing to descend to their burrows in the ocean trenches, evolution didn't force it to be fast, just inevitable, just efficient, just gigantic. But why did it get so big? The answer isn't just in its food, although it does feed on deep-sea fish and other squid. The answer lies in icy water saturated with oxygen. Here, the biological break that prevents invertebrate animals from growing beyond certain limits has simply broken down. And the scariest part? We know very little about it. Most specimens have been found dead, floating on the surface or in the stomachs of sperm whales. No one has ever filmed a live colossal squid in its natural habitat. She remains a ghost, a breathing myth, a giant we may never fully understand. Now imagine looking at the bottom of the Antarctic Ocean and seeing legs, long, thin, piercing through corals and sponges as if they were alien stilts. Common sea spiders found in temperate waters measure only a few centimeters, discrete creatures, almost invisible. In Antarctica, they have a wingspan of over 60 centimeters. Their tiny bodies support disproportionately long legs, giving them an appearance that seems straight out of a Lovecraftian nightmare. They aren't real spiders. They belong to the class Pycnogonida, a group so ancient and strange that scientists still debate their exact position on the evolutionary tree. They have existed for over 400 million years, surviving mass extinctions that wiped dinosaurs and megafauna off the map. And here's the most bizarre detail. They breathe through their own legs. They have no gills. They have no lungs. Oxygen simply diffuses through the surface of their long, thin legs. The longer the legs, the more oxygen enters. The cold allowed this. The abundance of oxygen forced growth. They don't fight, they don't chase, they stalk. They move like mechanical ghosts across the ocean floor, searching for their favorite prey. Starfish, anemones, sponges. When they find one, they pierce the victim's skin with a sharp proboscis, and they slowly suck out your internal organs, leaving only an empty shell behind. The process can take hours. They're in no hurry. After all, in extreme cold, nothing is rushed. Would you walk through a place where this crawls under your feet, where every step could crush a creature that looks like it came straight out of a 1950s science fiction movie? Antarctica is like that. Every inch of the ocean floor is inhabited by something strange, ancient, and too gigantic to exist anywhere else. Do you think a starfish has 5 arms? Think again. In Antarctica, some have more than 50 arms. This is no exaggeration. This is not a miscounting. It is unchecked evolution, pushing the boundaries of what we consider possible. Species such as Lebidiaster annulatus, they develop bodies so complex that they look more like alien creatures than terrestrial animals. Each arm can be up to 30 centimeters long, and the entire animal can exceed 60 centimeters in diameter, larger than a large pizza. Here, starfish don't just grow, they become brutal and active predators, hunting krill, small fish, and even other starfish. That's right, cannibalism is common. The more arms, the greater the advantage in capturing prey. The larger the body, the more efficient the metabolism in extreme cold. And they live for a very, very long time. Some Antarctic species can live more than 40 years, while tropical relatives barely reach 5. It's as if time here moves in slow motion. Slow growth, slow reproduction, slow death, a world where even the biological clock has been reprogrammed. Now imagine something bigger than a blue whale, not in weight, but in pure length. The Arctic lion's main jellyfish, Cyanea capillata, may exceed 30 meters in total length. Considering its tentacles, that's longer than most whales, longer than an articulated bus, longer than many dinosaurs. Its tentacles spread out like a living, pulsating forest, each strand containing thousands of stinging cells, nematocysts, ready to shoot venom at anything it touches, a slow, ancient, almost immortal predator. It doesn't hunt. It simply exists, floating, waiting for prey to become entangled in its biological web. Compare them to tropical jellyfish of the same family. They look like miniatures, toys. While a tropical jellyfish may have tentacles a few centimeters long, the Arctic lion's mane, jellyfish, extends its tentacles for tens of meters, creating an invisible and deadly barrier in the icy waters. The cold allowed life to extend, literally, and the longer the range, the larger the capture area. The greater the efficiency, the greater the chance of survival. In the microscopic world, even plankton has become gigantic. Copepods are tiny crustaceans, the base of the oceanic food chain. In tropical waters, they are invisible to the naked eye, measuring fractions of a millimeter. In Antarctica, some species reach up to size missing from original text, centimeter long, true monsters for the microcosm. It may not seem like much, but for them, this is the equivalent of an elephant wandering among ants. The increase in size gives them immense advantages: greater fat storage capacity, better resistance to fasting, and greater reproductive success. Even at the base of the food chain, gigantism dominates. But not everything grew. Some species followed the opposite path: polar dwarfism. Smaller fish mature faster. They reproduce earlier. They survive better when food is only available for a few months a year, during the brief bursts of productivity in the polar summer. In Antarctica, growing too large can be a death sentence. A large body requires more food. More food means more risk. And when winter arrives and food production plummets, the large ones starve, while the small ones survive on modest reserves. Here, evolution doesn't just reward the biggest, it rewards the most strategic. The scariest part: many of these species have hardly changed in millions of years. The environment is so stable, so predictable, that evolution has slowed drastically. Some creatures are practically living fossils, identical to ancestors that swam here 10, 20, even 30 million years ago. The frozen ocean doesn't demand rapid adaptation. It demands perfection and stability. And once you achieve that perfection, there's no reason to change until something changes. But here's the problem, the elephant in the room, the question nobody wants to ask, but that everyone needs to hear. What happens when a stable world begins to change? These giants were designed for a cold, dense, predictable, and oxygen-saturated planet, not for warming, not for oxygen loss, not for rapid change. As the oceans warm, and they are warming, that's not a debate, it's measured, oxygen levels decrease. Warm water retains less gas. The metabolism of animals speeds up, and giant bodies, which were once advantages, become a burden. Imagine carrying a 50-kilogram winter coat in the middle of summer. That's what's happening to these animals. Are we witnessing the silent collapse of an ancient world? A world that took millions of years to form and that could disappear in a few decades? What if, at this very moment, one of these giants is already shrinking? What if creatures that took millions of years to emerge are disappearing before our very eyes without anyone noticing? The cold created giants, but the heat may be dooming them all. And the worst part? We may never know. Because studying Antarctica is expensive, difficult, and dangerous, and when we finally return to measure, it may be too late. Now tell me, do you think these ice monsters will survive in our changing world, or are we about to lose creatures we never fully understood? Leave your opinion in the comments. Like the video if it changed your perspective on evolution, the fragility of life, and the limits of what is possible. And subscribe to the channel, because the next topic is even more disturbing. What if I told you there's a jellyfish more deadly than any other, and that it lives in aquatic environments, hot, not cold? A creature so small it fits in the palm of your hand, yet so lethal it can kill a grown human in under 5 minutes. If you want to discover the most lethal animal in the ocean, don't miss the next videos. See you in the depths.